Hey guys, what's up? It's your favorite teacher, and here we go with today's lesson. I believe this is class 15, and today we're actually going to be talking about dividing polynomials. Now we're going to see a lot of examples of dividing polynomials. We're actually going to see two methods. One method, or actually three examples. One example is with long divisions and a short polynomial or a small polynomial. We're going to see long division with two polynomials, and we're going to see synthetic division, right? So let's see these examples first. Some examples are from your book. Some examples are from an outside resource. And the page that we're doing on your book is section 3.3, which if I'm not mistaken is page 269, okay? So you can go ahead and look at that. So what are we know what polynomials are. We've seen addition of polynomials, which is basically combining like terms. We've seen multiplication of polynomials, which is using the distributive property in FOIL, but we've never really seen dividing polynomials. And in this class, I'm going to teach you how to divide polynomials. And then at the end of this video, just like I always do, I'm going to leave the work assigned. And here we go. So, dividing polynomials. Now, there are three things that when you're doing dividing polynomials by using long division, which is what we're going to see here, there are three basic steps. First is divide, then we multiply, and finally we subtract. Now, just like any normal long division problem, sometimes you're not going to have a remainder, you're going to have a quotient, and sometimes you're actually going to have a remainder just like you would do in any other long division problem. So let's see what I mean. The first example, this one is not in your book, okay? This is example 1 on page 269. It starts on page 269 and it ends on page 270. If it's not 269, it's 268, but I'm pretty sure you'll see it at the beginning of section 3.3. So we have x squared plus 9x plus 20 divided by x plus 5. So this is my dividend, which means this is what's going to go inside the house, or inside of we call it the house, or we call it the block, whatever you want to call it. X squared plus 9x plus 20, and we're dividing it by x plus 5. So now looking at what I wrote here on the side, the first thing we're going to do is we're going to divide. But what are we going to divide? Well, what we're actually going to divide first is we're going to divide the x squared with this x right here, okay? So what you're going to do is you're going to say, how much is x squared divided by x? Well, of course, you know that when you're dividing polynomials, when you're dividing exponents, you subtract the exponents, so basically that's going to be x. Next thing we're going to do is we're going to multiply. But what are we going to multiply? Well, we're going to multiply this x by x plus 5, okay? So x times 5, and that would be, and this is a plus of course, and that would be 5x. And then x times x is x squared. And just like you do in any normal division, you're going to subtract. Okay? So we're going to subtract 9x minus 5x is 4x. And of course, x squared minus x squared is 0. So then I just bring down the 20. That would be plus 20. And then what am I going to do now? Now I know I divided and I multiplied, right? But what else am I going to do? Well, we're going to start, so I divided, I multiplied, and I subtract. Now what am I going to do with this? Well, we're going to repeat the same steps. Divide, multiply, and subtract. The thing that I'm going to divide is actually 4x by x. And again, the exponents subtract, and 4x divided by x is 4, and it's positive 4. So we say plus 4. And then we're going to multiply. And we're going to multiply 4 times 5, and then 4 times x. So 4 times 5 is 20. And 4 times x is 4x. And we've divided, multiplied, and now the last step is to subtract. And of course, 4 minus 4 is 0, and 20 minus 20 is 0. So that's it. In this exercise, I actually get no remainder, and my quotient is x plus 4. And that's it. But sometimes you have remainders. Like we're going to see in example number 1 of your textbook, which is on page, or which begins on page 269 and actually ends on page 270. Okay, so we're going to do the same thing, and our dividend is going to be here, 6x squared minus 26x plus 12, and we're going to divide that by x minus 4. Okay, so what we're going to do now is we're going to do the same steps that we did. And we're actually going to divide 6x squared by x, and that's going to be 6x. And then we're going to multiply 6x times x minus 4. So 6 times x minus 4 is minus 24x. And then 6 times x, or 6x times x is 6x squared. And we're going to just subtract that. So we write it in a parentheses because what we do is we subtract and we distribute the negative sign. So basically 6 minus 6 is 0. Negative 26x minus 24x, that actually turns into a negative 26 plus 24, which is actually 2, or negative 2x. And then I bring down the 12, so plus 12. So again, all I did was negative 26 minus negative 24 is negative 2, and then I just brought down the 12, okay? Now we're going to repeat the same steps. So I'm going to divide. What am I going to divide? Negative 2x by x, and negative 2x by x is negative 2. So minus 2. And then I'm going to multiply, and negative 2 times negative 4 is plus 8, and negative 2 times x is minus 2x. And of course, I am going to subtract, which means I'm going to distribute that negative right here. And what you're going to do is negative 2x minus 2. Of course, that turns into negative 2x, or negative 2x plus 2x, which is 0. And then 12 minus negative 8, or 12 minus 8, excuse me, is 4. So I have a remainder of 4. Now here I had a remainder. In my previous example I didn't. So how do I express that? Well, you simply say that 6x squared minus 26x plus 12 divided by x minus 4 equals 6x minus 2 plus 4 over x minus 4. And that's it, guys. So that's pretty much how we do long division. Now we just saw simple polynomials. Real soon, and in the next example, what we're going to do is we're going to see how we do this, but with long polynomials, all right? Or long division with, very long polynomials as well. So we'll see. What we're going to do is in a couple of seconds, you guys are going to see the other example, all right? Long division, but now what we're going to do is we're going to use larger polynomials. So I got two examples, one that's not in your book and the other one that is in your book. This one is actually example number 2 on page 271 of your textbooks, so you guys can go ahead and review that one. And this one is from an external source that I found. So here we go. So we have 6x to the power of 4 minus 30x squared plus 24 divided by 2x squared minus 8. Now when you're using the dividend, okay, it's always good that you make sure that they're written in standard form. Now, standard form means that they're written in they're written in a way that the exponent is ordered from largest to smallest. And if there's any exponents missing, then you just have to add them in order to fill up the gaps. So, for example, we have 6x to the power of 4, but we don't have any term elevated to the power of 3 or cubed. So we're going to say plus 0x cubed minus 30x squared. We don't have a term that has an x, so we say plus 0x, and then plus 24. And then after that, we say 2x squared minus 8. So the steps that we're going to do are the same 3 steps that we saw in our previous example. Divide, multiply, subtract, and then repeat. Okay? So this is what I mean. You're going to divide 6x to the power of 4 by 2x squared. And I know this is really what I'm doing. I'm just doing it mentally, but I'm going to give you guys the opportunity to see what I'm doing, and that way you'll know. Remember that when you're dividing exponents, you divide them. So 6 divided by 2 is 3, and then you subtract the exponents. Okay, so you divide 6 by 2, which is 3, and then subtract 4 minus 2, which is 2. So that would be 3x squared. So 3x squared is actually going to be here. Right? And then, now that I've divided, my next step, you said it, is to multiply. So you're going to multiply 3x squared by 8. So 3x squared times 8 would actually be negative 24x squared. And then 3 times 2x is 6x to the power of 4. And then we're going to subtract that. Okay? And I'm not really going to do anything with the 0x cubed because it's 0. It's non-existent. I'm just using it to fill out a gap. So 6x to the power of 4 minus 6x to the power of 4 is 0. And negative 30 minus negative 24 is actually going to be negative 6x squared. And then I bring down the 24. So I divided, I multiplied, I subtracted, now I repeat, which means now I'm going to divide 6x squared by 2x squared, which is just going to be 3, or actually negative 6. X squared divided by 2x squared is going to be negative 3, and that's what I'm going to write here. And then you're going to multiply negative 3 times negative 8 is plus 24. And negative 3 times 2x squared is actually negative 6x squared. So I write in the parentheses and I distribute the negative. And negative 6x minus, or negative 6x squared minus 6x squared is 0. And 24 minus 24 is also 0. So all this is 0. And I have no remainder, and this is my answer. And it's very simple. It's not out of the ordinary. It's not, too difficult. Now example number 2 on page 271 says 8x to the power of 4 plus 6x squared minus 3x plus 1 divided by 2x squared minus x plus 2. And I know that seems long, a lot to say, and it looks like an equation for time travel, but it's really simple. I went ahead and did the first step. Now the first step is here is the same thing as the first step here, which means you write all your polynomials or your dividend in standard form, which is in order from largest exponent to smallest exponent. So I have 8x to the power of 4. I don't have an x cubed, so I just say plus 0x cubed plus 6x squared minus 3x plus 1 divided by 2x squared minus x plus 2. Now the first step is divide, so I'm going to divide 8x to the power of 4 by 2x squared. So 8x, or 8 divided by 2 is 4, and I subtract 4 minus 2, which is 2. So that would be 4x squared, which is what I'm going to write here. And then I divide it, so I multiply. So you're going to multiply 4x squared times 2, which is actually 8x squared. And it's positive. And this is a 6, so I know my marker's kind of running out of 8 there, but it's a 6. And then you're going to multiply 4x squared times x would be minus 4x cubed. And then finally 4x squared times 2x squared, which would be 8x to the power of 4. And I subtract. Distribute it, shoot a negative sign. And 8 minus 8 is 0. X to the power of 4. 0 minus negative 4 is actually plus 4x cubed. And 6 minus 8 is negative 2x squared. And I bring down the 3x. I don't need to write the 0x to the power of 4, so I'm going to go ahead and erase it. Now all I need to do is repeat. So once again, I'm going to divide 4x to the power of 3, or 4x cubed, by 2x squared, and 4 divided by 2 is 2, and 3 minus 2 is 1, so that's actually going to be 2x. Okay, so 3 minus 2 is 1, and 4 divided by 2, so that's actually 2x, so plus 2x. And what I'm going to do now is I'm going to multiply 2x times 2 is actually 4x, and it's plus 4x. And then 2x times x is minus 2x squared. And 2x times 2x squared is 4x cubed. Okay, so now I subtract. And 4 minus 4 is 0. 2 minus negative 2 is also 0. And negative 3 minus 4 is actually negative 7x. And I just bring down the 1. And I have a remainder. My remainder is, and let me write that better, negative 7x plus 1. That's my remainder. So what am I going to do now? That's it. That's my answer. I had to rearrange it, of course. It's really long. Like normally all you need to do is just say 4x squared plus 2x minus or remainder of negative 7x plus 1. But I don't know how your teacher does it or what book you're using. Or let me rephrase that. I don't know how many teachers do it or what book is being used. But I'm going to go ahead and do what the book does. And the book says that ax to the power of 4 minus 3x plus 1 equals, okay, sorry, I skipped one, sorry, plus 6x squared minus 3x plus 1 equals 2x squared minus x plus 2 times 4x squared plus 2x plus, and I'm going to go ahead and write down here, plus negative 7x plus 1. So that's how your book does it, alright? To be honest, personally, if you just write that it equals 4x squared plus 2x with the remainder of negative 7x plus 1, that's fine, but some versions of some books do it that way, okay? So now what we're going to see is synthetic division, alright? So go ahead, take a look at that, rewind the video, pause it, and then we're going to see actually the synthetic division part of our class for today, and then after that I'm going to give you guys the work. And here we go with the last example of the class, which is synthetic division. Now, you've had the opportunity to see long division with small polynomials, long division with large polynomials. You've had the opportunity to pause and rewind and look at the video. But here we're going to use synthetic division. Now, this is example number 3. That's on page 271 of your textbooks, if I'm not mistaken. And it's really simple. It's actually a lot simpler than long division. So I found 2 external sources, and then I'm going to do example number 3. So what is synthetic division? Synthetic division is a much simpler way of dividing these polynomials without having to go through the long division process. So what we're actually going to do is we're going to draw this, okay? And we're going to take the coefficients of each of the terms. Now you want to make sure that all of your polynomial coefficients or exponents are included. For example, if the highest exponent is 3, then you want to make sure that there's a 2 and you want to make sure that there's an x. If there isn't, then you had to add a 0. And we're going to see that one in our last example. But for now, we're just going to write the coefficients. So instead of writing 1x cubed, I write 1. Instead of writing 5x squared, I write 5. Instead of writing 7x, I write 7 and 2. And this. So there has to be a number here. So what you can do is two ways. Either say x plus 2 and then solve for x, which x equals negative 2. Or just understand that you have to reverse it. Meaning that if it's a plus, you write minus, and if it's a minus, you write plus. So this is actually going to be negative 2 here. And what you're going to do is you're going to bring down the 1. And then you're going to multiply. Negative 2 times 1 is negative 2. So that would be 5 plus negative 2, which is actually 3. And then negative 2 times 3, which is negative 6. And that would be 7 plus negative 6, which is 1. And then negative 2 times 1, which is negative 2. And negative 2 plus 2 is 0. And that means that there is no remainder here. Now, I know that the leading coefficient is going to be a 1. And you see this, you take x cubed and you divide it by x, and remember that you subtract the exponents, so this is actually 1x squared, and then you have 5x squared, so you divide the exponents, and 2 minus 1 is 1, so this is actually going to be 3x, and of course x and x cancel out, so plus 1, which means that your answer is 1x squared plus 3x plus 1. See how easy it is? It's really simple. It's really short. Let's look at this one. Same deal, guys. So we're going to make sure that, first of all, if the largest coefficient, or the largest exponent is a 3, that I have a 2 and a 1 to follow, and then I don't have to add any zeros around there. I don't, so all I do is I draw this structure again, and I write the leading coefficient, which would be 1, minus 2, minus 5, and 6, and it says x minus 3, so we're actually going to divide it by the opposite. It's kind of like what I did here when I solved x minus 2, or x plus 2, excuse me, and it gave me x minus 2. Well, if this is a minus 3, I'm just going to write plus 3. Had it been minus or plus like I did here, I would have written minus. So I bring down to 1. 3 times 1 is 3, so negative 2 plus 3 equals 1. And then 3 times 3 is 3. So negative 5 plus 3 is actually negative 2. And then 3 times negative 2 is negative 6. And 6 plus negative 6 is 0. And now I do the x's. So x cubed divided by x is actually x squared, so that would be 1x squared. And then 2x squared divided by x, which would be x, or x squared divided by x, which would be x, so that would be plus x, or plus 1x. And of course, these x's cancel out, so that would be minus 2. Or you can also write this as x squared plus x minus 2. And that's it. Those two examples are pretty simple, and so is the one in your textbook, actually. It's just that here you have to be careful, because I have the leading coefficient is 3, I have an x squared, but I don't have an x. So I have to do a little bit of rearranging, and usually when I have to do that kind of rearranging, that means I'm going to have a remainder. So you're going to draw this again, and you're going to say, well, 2 minus 7, which would be your x squared, but since I don't have an x, like after x squared I go straight to 5, so that means I'm missing an x term here, so I just say 0, 5. And I have a minus 3, so that means that here I'm actually going to put the opposite of minus 3, which is positive 3, and then you're going to bring down this number here, so 3 times 2 is 6, negative 7 plus 6 is actually negative 1, and then you have 3 times negative 1, which is negative 3, and 0 plus negative 3, which is negative 3, and 3 times negative 3, which is 9, or negative 9, and 5 plus negative 9, which is actually negative 4. So I have a remainder. This is my remainder right here, 4. And let me just rewrite this. So remember, now I do the same thing with the x's. X cubed divided by x would be x squared, so this is going to be 2x squared. X squared divided by x is x, so this is actually going to be minus 1x or minus x, however you want to write it. Okay. And then you have so as I was saying, and then you have this one, which would be 0x, so there you go, I don't need to write it, and this one would be minus 3, and the remainder of negative 4. So how do I rewrite that? Well, the way your book, so how do I write my answer? So here's my answer, but how do I write my answer? How do I express it? Your textbook expresses it in a very weird way, at least weird to me, because again, it's more of a preference style of the authors of the book, but I'm going to give you guys a minute to look at what I did, and then we're going to write the answer the way they have it in your book. And I am going to be back in like 3 seconds. So here we go. So what you're going to say is you're going to say 2x squared, or 2x squared. You're going to say x minus 3 times 2x squared minus x minus 3, and then minus 4. And here you're just going to write 2x cubed minus 7x squared plus 5 equals. And that's it, guys. So that's synthetic division. It's a lot simpler and a lot faster than the long division one, which is why it's really one of the most commonly used whenever dividing polynomials, okay? So if you guys take standardized testing or whatever, you're actually going to use the synthetic division a lot, or a lot more common, because it's faster. So what are you going to do now? Well, you're going to go to page 274, and you're going to work on problem 273 and 274. You're going to go to page 273 and 274, and you're going to work on problems 3, 9, 19, and 31. Ladies and gentlemen, again, that is pages 273 and 274, problems number 3, number 9, 19, and 31. Ladies and gentlemen, that's it for this class. This is going to be the last video for this class, okay? After that, I'm going to upload a review for your math final, ladies and gentlemen. Remember that all assignments that are not handed in by 15 will be a 0. Please, ladies and gentlemen, I don't want to put myself in that awkward situation. So this is your favorite teacher saying goodbye. Stay safe, and we're going to see each other soon, sooner than you think.